So, hello everyone, welcome back to the videos on software engineering. We actually were discussing about functional independence, and we have seen that functional independence is achieved by developing modules with single-minded functions and a version of excessive interaction with other modules. So, in understanding functional independence, we need to take care of two concepts. The one is cohesion, another is coupling. We have seen that cohesion means that how much a module can work on its own, that is what strength it has, relative strength should a module have, and coupling is the relative interdependence among different modules. So we will see now what are the types of cohesions and what are type of couplings that do exist in software development. So first we will go with cohesions. The first type of cohesion is functional cohesion, and we require such cohesions in our software product. That means this is the highest level of cohesion that is desired in any type of software development. A functionally cohesive module contains elements that all contribute to the execution of one and only one problem related task. In your program exercises, you must have created modules, you must have created functions, right? And the function, actually, whatever statements do you write within the function, all those functions uh, are uh, are converging toward one objective, that is what is be the name of that function. Like if I create a function by the name called sum, and I pass two parameters a and b, then in that case all the statements in that function is working towards a common goal, that is computation of the summation of the values of a and b, right? That's what we mean, that when you create a function, you all the statements within the body of the function actually are cohesive, and they are actually working towards the common goal, like computation of a sine of an angle or calculate net employee of the salary, right? So once you create functions in a program, that means you are cohesively binding all those statements within the function, and it's known as functional cohesion. The second type of cohesion is called sequential cohesion. A sequential cohesion generally consists of those elements that are involved in activities such that the output of one activity serves as an input of another activity. If I put if I write some statement like, if I initialize the value of a to 1 and then I write print a, right? Then these two statements, a is equal to 1 and print a, are sequentially related. A is equal to 1 is an assignment operator. Nature of the assignment, the statement is different. Print a is a different statement. It's a different statement. It's an output, and it is a processing element, right? Both are different, but we have put them in sequence, and because of the sequential nature they are cohesive. That means if I want to print the value of a before initializing it, it won't work, it will give you an error, right? That's why we call them that these two things are sequentially related and they are sequentially cohesive. Another example is a module can read and validate customer record. So for validating customer record, you need to read the record first. If you do not read the record, you cannot validate it. So reading the record and validating the record are two different functionalities, two different set of statements, right? But they are sequentially related to each other, and that's why they are called sequentially cohesive in nature. The third cohesion is called communicational cohesion. Communicational cohesion means that when we talk, when we have different functionalities, when we have different views, and all those views depends upon a single data of communication, then we call it as a communicational cohesion. Likewise, if I have a record of data like students, and I want to fetch out the branch of student, I want to fetch out in which year he is, I want to fetch out what is the CPI, or what courses does he has studied. So all these things are related to one entity, what is known as student, right? So all these functionalities that I want to avail, right, it will depend on one record, one entity, that is student. all those things is communicationally cohesive. Likewise, the example here says that we would find a title of a book, the price of a book, the publisher of the book, and the author of the book. The four activities are related because they all work on the same input data, that is the book, which makes the model communicationally cohesive. The fourth one is the procedural cohesive. A procedural cohesive means when we put in two elements which are possibly unrelated activities, right? We put in two things together and we want to execute one by one sequentially, right? The procedure will actually takes care of executing multiple unrelated activities in some sequence, right? So that's why when we create a procedure, we call it as a procedural cohesion. When we put different activities that although are different in nature and different in data, but they are coming because of the procedure, right? Suppose I have two tables, table A and table B, both have 100 elements, and I want to find the average of that particular tables. So I write a code something like this. When I create a procedure called compute table A average and compute table B average, right? So this is a procedure. So it uses table A and table B and returns the average of table A and table B. Then it initializes two variables A total and B total, and then it iterates both the tables one by one, considering table A first and table B first, and finally it will populate this table A average and table B average, and then we end the module. So module and end module is the tags. If you see here, the first and the last tag, they define the procedure. And a table A and table B, although they are unrelated, but this procedure actually calls these two tables together. Okay, so table A and table B are cohesive because of the procedure, nature of the procedure. And table A is first called and table B is second called, so they are sequentially cohesive as well. Then the next one is called temporal cohesion. Temporal cohesion means when we use the word called temporal data, or temporal words generally signifies something related to time, right? When you have multiple elements, multiple instructions in a program, and we arrange those statements or those instructions with respect to the timing of the program, we know call those instructions are part of a temporal cohesion. Like some activities, some instructions should be initialized at the beginning of a program, and something should be closed at the end of the program. So, like file, if you create a file, file.open will be actually in the initialization of the file, right? If you create multiple files, you can close all those files at one point, right? And then you can see that all the file pointers are closed. Okay, so closing all file pointers at the end of the program and opening them at the initial of the program, are you are segregating them with respect to time, right? Execution time of the program. So that's why those statements that come together due to the execution time of the program is known as temporal cohesion. Then there's something called logical cohesion. Logical cohesion means that a cohesive module is one whose elements contribute to activities of the same general category, in which the activity or activities to be expected are selected outside the module. That something outside is triggering you, and now you are putting those things together. It can be understood with this diagram, this code, that I have a module that maintained master file. Okay, it uses an input flag. Okay, input flag. If the input flag is 1, right, this flag is coming from the some external entity. They are giving you this input flag. Based on the logic of the input flag, you are adding a record in the master file. If the input flag is 2, you are deleting a record from the record. If the input flag is 3, you are editing the record. So these records, whatever elements are there in the records, add record to a file or delete employee from record or edit employee record, These statements are affected with the because of a logic, right? This logic is governed by some other activities outside the scope of the module, right? So that's why they are called as logical cohesion. The last one is called coincidental cohesion, and this is the lowest of the cohesion. And generally, it happens that when we keep on writing the code, we don't think of these cohesions. We keep on writing the code as per our own convenience. So elements do come together, and the code actually executes and gives us the output. But the thing is, these are very loosely written codes, and then it's very hard to manage these codes. So that's why this is known as coincidental cohesion, that modules, that instructions come together but due to cohesion, the coincidence only. Likewise, there are seven cohesions. We have five coupling as well, right? So the first type of coupling, this is a decision tree of the cohesion. I will just pause it for you. Can pause this video and you can study this particular decision tree and keep it in mind, because this will help you in deciding. If I give you a scenario, you can decide which type of cohesion it is, right? Now coming to the coupling is the measure of interconnection among modules in a software structure. A software generally strives for the lowest coupling possible. That you cannot say that I will not have any coupling, right? I will have a totally decoupled system, because nothing can work in isolation. So the coupling is needed actually, but there should be some lowest level of coupling, right? First type of coupling that is desired is called as data coupling. This is more desirable. Two modules are data coupled if they communicate through parameters where each parameter is an elementary piece of data. That means an integer or float or character. So you have done this when you created functions and like sum. When you created sum and you pass a comma b, so when you call this sum with 1 comma 2, you are coupling the main function with the function sum, right? You by passing actual data, right? 1 comma 2 is actual data that you are passing. So that's why you are doing a data coupling. When you do pass by value, it is called as data coupling. Next, time coupling on the other hand is when we don't pass the data, but we pass the complete data structure as a parameter, right? Like when we pass a list, or when we pass an array, when we pass a pointer completely to a function, then it is known as stamp coupling. Like stamp generally means an address, right? So this stamp means an address. So array is an address, list and an address, pointer itself is an address. So when you pass an address completely is a parameter between two functions, or two modules, right? So then those modules are coupled using stamp coupling concept. Control coupling, on the other hand, is a coupling in which two modules are coupled based on the logic or a flag or a control parameter. Likewise, if I say module 1 gives you a flag input or control input, so if the flag is 1, it goes to A. If the flag is 0, it goes to B. Something like that sort, that if I want to check whether a number is prime or not, so I will pass this number to a function. The function will create a logic to find whether it is a prime or not. If it is a prime, it will return 1. If it is not a prime, it will return 0. So when it returns 1 to the main function will print it is a prime number. When the function returns 0, the main function will say it is not a prime number. So depending upon 1 and 0, you are printing two different options, right? So that's the control coupling. When we actually pass data, but the data itself is not a data which is going to process. It is a control data, right? It is a control elements. The fourth is called common coupling. Common coupling takes place when a number of modules access the same data item in a global data space. So you are having a global data space and you have a data stored in a global space. Now multiple modules are going to access that particular element, right? And this is not desirable ideally. Why? Because most of them will going to access and they can even change it. So who is going to change that module? You will have need to track that. So this type of things generally are required in software development, but they are least desirable, right? And finally, it's called content coupling, which is the least desirable coupling. Two modules are said to be content coupled if one module branches into another module and modifies data within another module, right? Like I have a function f1 with integer a, so it executes this function print function 1, it adds 2 to a and go, and then it has a label called go to f2a, right? f2a is inside the function 2, right? It's not calling the function 1 is not calling function 2. Instead what it's doing is it's going directly inside the function 2 and printing add f2a, right? So you're branching it without any condition, without any calling, right? So this is called as content coupling and it is not desirable. We don't use it anymore. So that was all about cohesion and coupling in this part. I hope you understand what is coupling, what is cohesion, what are the different type of coupling and what different type of cohesions. If you have any questions, do write it down, like the video, share the video, and let me know if you have any issues. Thank you very much. Have a nice day.